Welcome. So in this video, we're going to take a look at a lab where we determine the equilibrium constant of a reaction. And the reaction we're going to be looking at is this one right here. It's between the iron ion and the thiocyanate ion, and they're going to make this complex ion. Whoops, I got the charge wrong here. They're going to make a complex ion, which looks like this. It's got a 2+ charge, iron thiocyanate. And this is a system that is commonly used because we can use the spectrophotometer to measure the concentration. So these two reactants, the iron and the thiocyanate, you can see them right here. This is my iron solution. This is my thiocyanate solution, and they're both clear, right? They're these colorless liquids here. When they mix together, the product of this reaction is going to be kind of this rust red color. So we'll be able to observe it, and then we'll be able to quantify how much product we made using a spectrophotometer. And I wanted to go over as much lab technique as possible with this in this one video. So I want to show you actually how I made these two initial solutions. So one thing is the way that you get an aqueous ion is by dissolving an ionic compound in water. So to make this SCN minus solution, what I did is I took some solid KFeSCN, so it's potassium thiocyanate, and then thinking about our solubility rules, since this contains an alkali metal, potassium, we know this one's going to be soluble. So I weighed out some solid, and I did that on a balance and using what I call the weigh boat right here. So I weighed out my solid, and then I took an empty volumetric flask, and I added the solid to my volumetric flask, and then I added water until it reached this line. So whenever you're making a solution, you always want to use a volumetric flask. That's what these things are called right here. We shouldn't be using beakers. We shouldn't be using Erlenmeyer flasks. We want to use a volumetric flask. It's the most accurate glassware here. And then this one right here, the iron thiocyanate, I didn't quite finish making the solution yet. I don't know if you can see this line right here, but what I did is I added solid. I added 0.2 grams of this iron nitrate. Then I added some water to it and swirled it around to make sure it dissolved. And now what I'm going to do is I'm going to take my squirt bottle and I'm going to slowly and carefully fill it the rest of the way up to this line right here. And so that is how you make a solution. And we also want to make sure our solutions are mixed pretty well. So I am going to get a piece of parafilm, which is this stuff right here. It's kind of like fancy lab saran wrap is basically what this is. And it gets kind of tricky. You have to peel it off its backing. Okay, and you have this little piece of kind of nice saran wrap. And what this does is this can make like a really tight seal over a container. And so now I've got a seal over it. And so this is called inverting. So I'm inverting my flask. And of course, I'm wearing goggles while I'm doing this as well. So this is the way that I'm going to mix my solution in my volumetric flask. And then I'm going to do the same thing with this one over here. So that's just a little bit about solution making. And then I'm going to pause and get some more things set up. All right, so remember that we mentioned earlier that we are going to use this equilibrium system because the product of this reaction is this kind of rusty red color. And we're going to use spectrophotometry to determine the concentration of the product when we set up one of these equilibrium systems. But in order to use spectrophotometry, we need to set up a set of standards. Okay, so what we're going to do is here is I made some solutions here, if you can see these variety of colors, with varying concentrations of iron thiocyanate. So that's this red stuff right here is the iron thiocyanate. And you can see that this one has no iron thiocyanate. It's clear. So this is our 0. And then we've got more and greater concentration. So I have carefully measured these ones, and we know the exact concentration of iron thiocyanate in each of these solutions. And then what we're going to do is we are going to use one of these guys right here. This is called a plastic, it's a transfer pipette. And we're going to pipette some of this solution into this right here. So this is a cuvette. Okay, so we're going to pipette some into this cuvette right here. And then what the cuvette does is it goes here into this spectrophotometer. And we have these really cool small spectrophotometers that connect to our laptops. And so in a moment, I will kind of turn my screen around so you can see what this looks like on a laptop. So, but what I'll be doing though is I'm going to pipette some of this solution into this cuvette, and then I'm going to put it into the spectrophotometer. And then what the spectrophotometer does is it shines a light through the solution, and it measures, it compares how much light it's shined in versus how much light comes through the other side. So you can figure out how much light is absorbed. And the darker the solution, the more light will be absorbed. The lighter solution, so this one, we're going to say 0 light is absorbed. So we're going to use this as our 0. This one's the darkest. It will have the highest absorbance. And we should come up with this nice linear relationship between concentration and absorbance. What we're doing now is we have our standards in these little cuvettes here, and we're going to place them into the spectrophotometer, and you'll be able to see the readout on the screen here. So now I'm placing it in the spectrophotometer, and you'll see the absorbance of this solution is 0.679. So what I'm going to do is I'm going to click this button that says keep, and I'm going to type in the concentration of this solution, which is known because I made the solution. Okay, so it's 0.0002 molar iron thiocyanate. And then I am going to take that out, and I'm going to put in another solution. This one's a little bit more concentrated. And then I am going to hit the keep button and type in the molarity. It's 0.0004 molar. And then what I'm going to do is I'm going to click stop to end the data collection. And then there's this button right here that will give me let's see, I think it's this one right here, that will give me a linear best fit line here, which isn't turning out super pretty here. So I think the slope here is 2,000. Oh, here we go. That's a better view. Okay, the slope is 2,400. So we're going to use that. That's our relationship between concentration and absorbance for iron thiocyanate. And then we will use this for part 2 of our experiment. All right, so to summarize what we just did here is we measured the absorbance of a few solutions of iron thiocyanate with known concentration, and then we measured the absorbance and we're able to plot this. And we did this all using this piece of lab equipment, the SpectroBees here, and it made a graph for us, and we saw that the slope of this line was 2,410. So if you think of this as a linear graph here, y equals mx, so the slope is the m value right here. So what this means is the absorbance is 2,410 times the concentration in molarity. And this will help us later in part 2 of this lab, because we're going to make a solution that's an unknown, and we're going to measure the absorbance of that solution, and we'll be able to use this relationship to figure out what the concentration is. So if we know the absorbance, we can find the molarity, and that's what we're going to do with this info in the next video.